This is station 9, question 1, B, question 2, A, question 3, acid, question 4, that blue-purple colour, station 10, heterogeneous mixture is Y, question 6, Gatorade, question 7, B, heterogeneous mixture. Station 11, question 8, Z, because it still has solid in there. In other words, it can't dissolve at this temperature. It must be saturated. Question 9, the colloid is the one that will scatter light. This is a solution. It doesn't scatter. This is a colloid, and you can see the beam of light in there. So A is the colloid. Station 12, the substance that conducts electricity, the pencil lead, this graphite, and the magnesium. The one that doesn't is the wood. This is a physical property, electrical conductivity. Station 13, if you look at the chart, the substance with the highest melting point, where it goes from solid to liquid, is iron. Substance solid at 1500 Celsius, iron. Substance is liquid over the least temperature range, water. In which state is salt at 1800 Celsius? It's a liquid. 12. A would be sublimation, B would be condensation, C would be melting, D would be vaporization or evaporation. 13, you're adding energy whenever you go to a more energetically active state. So A, C, and D. 14, these particles can have more speed and higher energy. They have greater kinetic energy and they move faster. 15, the more dense liquid is B because A is floating upon it. It's oil and water. 16, this is a suspension and the particles will settle out heaviest at the bottom. There's all sorts of different things in there, so it's heterogeneous. This one is a colloid, this is a solution. 15, if it does not scatter light, it must be a solution. Solution particles are too small to scatter light. 18, least kinetic energy will occur in a Bose-Einstein condensate at a few billionths of a degree above absolute zero. 16, the current room temperature for question 19 is 22 Celsius. The boiling point of water in a metric system is 100 Celsius. 200 K in the Celsius scale would be, since the Kelvin scale starts at minus 273, that would be obviously minus 73 Celsius. And what's minus 273 degrees C in the Kelvin scale? That is zero, absolute zero Kelvin. 23, getting fresh water from salt water, it's called distillation. 24, the mixture that's not like the others. Well, this is heterogeneous, this is heterogeneous, this is homogeneous, this is a solution. 17, question 25, if they were liquid, the true statement would be B, substance A would float on top of substance B. 26, if they were solid, B would have the greater mass, more particles per unit of volume. 18, question 29, most rusting is going to happen when you've got an electrolyte like water plus acid or salt, and of course oxygen and of course iron. If you read this paragraph, it's talking about sacrificial protection, where you use a metal that is more reactive than iron to kind of take the bullet for the corrosion. So when you look at this, you can see that 2, which is steel wrapped in copper, copper's less reactive than iron, so the iron's doing the reacting and getting rusty. When you just have a steel nail, it's going to rust anyway, so that's rusting. And of course, if you wrap it in magnesium, the magnesium is more reactive than the iron, so the iron doesn't get a chance to react, and therefore the magnesium corrodes and the iron stays fresh and irony without any rust. So it's protected by the magnesium. So they'll put this on bridges, on boats, and it helps keep the boat and the bridge not rusty in that salty environment. It's called sacrificial protection. Station 19. The chemical reaction in each case. Well, for A is the apple. You can see the browning of the apple due to exposure to oxygen, so it's oxidizing and going brown. That's a color change. B, the match, color change. C, bubbles of gas, and of course temperature decreases. It's an endothermic reaction. And D, the yeast and the hydrogen peroxide. You're going to get bubbles of gas forming and an increase in temperature. It's an exothermic reaction. 20. The apple turning brown in air is oxidation. Matter changes that aren't chemical. Well, vinegar to baking soda is chemical. Burning a piece of wood is chemical. It's combustion. Melting ice and boiling it, that's not a chemical change, that's a physical change. Well, we've got here milky white solid forming, so that's a precipitation. Okay, formation of a precipitate. Color change. Alright, in this one we're matching the physical separation process to the vocabulary term. A is chromatography, B is gravity filtration, and C is distillation. Station 22, we're looking for the independent variable, that's going to be the amount of fertilizer. The dependent variable is growth rate, and the controlled variables are everything else. That's the type of plant, the type of soil, the amount of water, and the amount of light. They're all controls. Changes that don't change the identity of substance would be those where you're just changing state. So that's melting is changing state, freezing is changing state, sublimation is changing state, but burning, that's a chemical change. Station 24. For 38, C would be a mixture, it's heterogeneous. B is a mixture, it's a solution, alloys are a solution of one metal in another. A is just pure copper, so that's a pure substance. 39, the solution again. Copper is a pure substance, but Y, the brass, that's the one which is a solution. It's an alloy. And of course 39Z, alcohol here is water and alcohol in solution. Okay, so that's a solution. Y and Z are solutions. Out of number 40, the pure substance. Well, copper is just all atoms of copper, that's pure. Copper sulfate is a pure substance, it's a compound. They are chemically combined. And C, oxygen, it's a pure substance. Air, though, is a mixture. It's a solution of oxygen, nitrogen, carbon dioxide, and of course pollutants and trace gases like argon, etc. Okay. Station 25 was to make determination of the density of the object. So you'll do that doing the immersion method. Fill this to 100, add that, you get the volume. Mass the car, you find the mass of the car, now you've got the volume. So mass divided by volume will give you the density. Question 27. The order of layers from the top of the beaker. Well, it's going to be least dense at the top, so D's at the top. And then the next one, B. And then the next one, C. And the next one, A. So that is choice D. Okay. That's that. If you're not sure, study up.